Talked about quadratics, shown how to graph them, talked about the domain, and how to find the vertex, and whether it's a maximum or a minimum. So a question that inevitably comes up on things like this is, so what? What's the big deal? So we can find all this information out. What difference does that make? So one of the ways that we can show what difference that makes and why it's important is a question like this, the dreaded word problem. But we'll work through this and show you that uh, a lot of times, like word problems, the hardest part is figuring out what is being asked. So we have this problem here. The function f of x equals a negative 0.025 x squared plus x plus 6 models the daily profit of a company that manufactures X computers daily. How many computers should be manufactured each day to maximize profit? So, what they're wanting to know is, what's the maximum point of this function? If you remember, the maximum or minimum of a quadratic is at its vertex. So we can look at this equation here and see a couple things. F of x equals negative 0.025 x squared plus x plus 6. All right, first thing we should notice is that this a over here, a term, this negative 0.025, since a is less than 0, your graph is going to have a maximum, which kind of makes sense because they want us to find out what the maximum profit is going to be. So it's going to open down because a is less than 0. So they want to know what the maximum profit is. That's going to happen at your vertex. So how do we find the vertex? Well, if you remember, when the equation is given in standard form like this, your h, which is your x coordinate value of the vertex, your h is equal to negative b over 2a. So your b is here at 1. So that equals a negative 1 divided by 2 times a negative 0.025. Okay? So at this point, we get our calculator. Slowly. Come on, calculator. Let's try that again. There we go. So, and then we say, all right, 2 times 0.025 is 0.05. A negative 1 divided by a negative 0.05, no, we did a minus that time, a negative 1 divided by, there we go, a negative 0.05, oh, I see what it is. We'll just ignore the negatives. 1 divided by 0.05 equals 20. All right? So h is equal to 20. And that's our answer. They want to know how many computers should be manufactured each day to maximize profit. Well, h is 20. That means the maximum value that you're going to have is going to be at 20. And if we wanted to, we could calculate that out. We could say 20 times 20, so that's 400. So we could say f at 20 equals negative 0.025 times 400 plus 20 plus 6. So 400 times 0.025 negative is negative 10 plus 20 plus 6. So that's 16. So your vertex is going to be at 20 and 16. I've already graphed this out, so we can see there's 20 and there's 16. Now, hopefully, this company represents thousands of dollars, or maybe even millions of dollars, because if you're making $16 a day, that hardly seems worth it. But that's beside the point. The question was, how many computers should be manufactured every day to maximize profit? The answer is 20. In order to maximize profit, you want to make 20, and then that vertex point is at 20 and 16. So that's a practical use of this type of problem. When you want to find out what the maximum or minimum is, again, all they're asking for is what's that vertex point? What's the x coordinate of that vertex? And in this case, it's going to be 20.